All right, this is a lovely little lake in southwestern Iceland with a really cool geologic history. This is pronounced, I hope I get it right, Grænavatn, and it translates to green lake. So it's a great name for this nice little lake here. We'll talk about the color here in a little bit, but mainly we want to look at the shape of this lake and discuss its volcanic history. So it's a fairly small lake, maybe, I don't know, 300 yards, 300 meters-ish across. Not sure how deep it is, but let's contrast that with a similar feature just over the hill. And there's actually several of these, and these all formed around the same time, between 11 to 7,000 years ago. So at that time, we don't have evidence that there were any glaciers here. So the origin of these craters, it's going to have something to do with something other than ice. So you can see a similar smaller crater over here, quite broad but not very tall, and then there's another one just over the hill here, and I think there's even more to the south. We're looking south there towards the coast of Iceland. So what these are, these depressions, this green lake, these are volcanic features called maars, M-A-A-R. And the way these form is when we have magma ascending towards the surface and interacting with groundwater at depth. That groundwater, because of the heat of the magma, flashes into steam and creates what we call a phreatic eruption, P-H-R-E-A-T-I-C, phreatic. So it's a steam-driven eruption. So that means that the eruption becomes quite explosive, and what it does is it excavates a large crater. So it excavates a big crater at the surface, and what's happening as the water's flashing to steam is it's just blowing out big chunks of rock and throwing them around the landscape. And we can see some of these big blocks here. That one's maybe, you know, 7-8 feet in diameter. Another big one over here. There's several large ones strewn around over by the cars. We can see this upper rim here with all these angular blocks of rock. And these are all these kind of weathered light gray to tan basalts. So these are older materials that got blown out of the crater as this eruption was commencing. And then later, what happened was that magma and water, so initially the magma's interacting with the water and flashing to steam, and they're just blowing out chunks of rock sitting above the water or around the water. Eventually though, you excavate enough material that you reduce the pressure on the lava beneath the magma, and then you create a situation where you can start to erupt some of the actual magma that's mixing with the water. And you can see we just transitioned here just ahead into a darker material. So these big blocks of rock were thrown out early in the eruption, but later in the eruption the lava and water were interacting, and the water was quickly quenching and cooling the lava, but the explosive conditions continued. And so what we get is a layer of material that happened after that initial steam-driven or phreatic eruption, and this is what we call a phreatomagmatic eruption. So there's a spelling bee word for you for the next spelling bee challenge. And phreatomagmatic is when we have steam and magma generating the eruptive phase. So if we come down here, we can see in the walls of this crater, on this upper layer, that kind of, you can follow that around over to the other side. And real quick, we can also see that the crater rim is significantly taller on this side, the east side and the northeast side, than it is over here on the west side. And that presumably might indicate that the wind was blowing, as it often does here in Iceland, from the west or the southwest, which would be to your right, or to the northeast, which makes a lot of sense. So a lot of that material being thrown out of the crater was deposited on the north or east sides and built up all this material. But what we can see here is the actual lava itself that eruptive sequence eventually tapped into. So these are what we call juvenile class or juvenile material. It's actually the lava itself, the lava and magma that was causing the eruption. At this point in the eruption, it finally was interacting with water with not much pressure or water sitting above it, that it was able to be thrown out of the vent and be deposited on the crater walls. So we don't see in the lower part any of this juvenile material. We just see those older light tan and light gray blocks of basalt. That was sort of the initial phreatic phase that cleared out the crater, created the crater, and eventually set the stage for this phreatomagmatic eruption. You can see this stuff's not very well consolidated. It's all kind of falling apart back here. So this is just shredded up lava that's been thrown out of the crater and then deposited along the rim here. So a nice little story, beautiful little lake. The color of the lake, no idea, but best hypothesis is this. So you can see this prominent ridge here, trending from the southwest off to the northeast. Like a lot of these, this is all driven by the plate boundary. A lot of these fissure eruptions and volcanic eruptions in general tend to be along that trend. This is also perpendicular to the extension. As the two plates separate, we get a lot of faults that also trend this way. Over here, you might be able to make out a parking area and a patch of yellow ground that the sun's just starting to hit. Another one right here, just above these grain silos. And then another one over here behind this beautiful little blue house. And these are all places where there's geothermal activity. So the groundwater has moved downward, interacted with either magma or hot rocks, become more acidic. And as that water has then been moved towards the surface, we can see that it's killed a lot of the vegetation, created some hot springs, fumaroles, little mud pots, which that's Seltoon over there, and I did a video from that area. But the point is that the groundwater here is hot, it's somewhat acidic. We can see the bleached out landscape in places along the ridge. And because this lake, this depression, is just filled in with groundwater, there's no streams or little creeks running into it. I would assume then that the groundwater, being very rich in some of those sulfuric and acidic materials, is moving through the rocks. It's dissolving away some of the elements and minerals in the rocks, and that's why this lake is such this beautiful, gorgeous green color. I'm not a chemist, so I would have no clue as to what element or chemical stew is responsible for the color, but there's a quick stab at some observations and hopefully a good field hypothesis. So Grænavatn, Green Lake, a maar, a volcanic maar created by groundwater and magma interacting, becoming explosive, excavating a crater that's much wider across than it is tall here in Iceland.